Awesome. Let's get into this. So first, thanks to our sponsors. Jason rattled through all these companies. Everybody know we're all interrelated. So yeah, thank you for that. If you like this, you want to keep going, I do a packet decoding class that's kind of fun. That's coming up in the next couple of weeks. I also do a network. We're doing a network threat hunting class just after that. That's a lot of the basics behind what I'm going to actually go through and talk about today. That one also, you can go through this hands-on labs. You get to do it yourself too. That's kind of fun. But when I go through, so really what I wanted to do is I wanted to go through kind of a full hunt. I wanted to go through and kind of show, so what are the steps from start to finish? What is it you want to go through and do? So as part of that, I'm going to go through and follow that runbook we've defined, which is, step one, identify connection persistency. Do I have hosts that are in constant communications with folks out on the internet? If so, let's dive deeper on those. Next, identify, is there a business need? Can I look at that connection and say, oh yeah, I know why we do that connection. That's patching the systems. That's part of our internal messaging program, or, there's some identifiable business need. If there's not, okay, let's do a protocol analysis. And if not, then we need to start looking at the two endpoints. I have external before internal. But if you're in an environment where, let's say, everybody has sysmon running on their systems and you can ID 3 applications connecting on the network, hey, great, I would investigate the internal IP address first. Most sites don't have that level of detail, so it's usually a little easier to try and investigate the external one first, then move to internal. And as part of threat hunting, we want to make sure that we're not doing anything that's going to be detectable by the adversary. So if we go through this process and say, hey, I want to know what process was making this connection on that system. Let me go log into that box and start listing out running processes. Well, of course, if there's an attacker on that box, they may see that. They may detect it. We may give up our hand. So we don't want to do anything active like that until we've actually gone into incident response mode. So threat hunting, everything we do should be the adversary has no idea we're actually doing it. As far as tools we're going to use, I'm going to use Zeek. Zeek will go through and give us a record of all the packets that went by in and out of the internet link. So what we're doing is we're capturing traffic as it crossed our perimeter out towards the internet, and then the replies that came back in again. So we're going to go in and take a look at that. RITA is going to go through and do the first pass through the Zeek logs to help us identify what are potential command and control sessions that we need to take a look at. We'll use various research tools after that, and then we'll use various data formatting tools after that. And here is the PCAP we're going to be working with. So this is roughly a little over 3 gig file with 4 million packets in it. It's a decent size. What I wanted to go for was a PCAP that kind of represents like a half a gig to a gig connection to the internet. What might you see for average traffic in the course of a day? I wanted something that wasn't just, oh, hey, everything's coming from one single IP or something along those lines, just to make this a little bit more real world as far as how to go through it. There's about 113 unique TCP sessions in it. So, I think this is a good data set to kind of represent what the average person may run into when they're doing a hunt. So the first thing I did is I ran this through Zeek. My -C switch tells it, don't do a CRC check. In other words, I couldn't remember where this traffic was generated. It may have been generated on one of the hosts that we were actually trying to capture traffic for. And anything leaving that system, the CRC gets generated on the network interface after the capture point. You'll see a bad CRC check. So basically, if you ever read a PCAP with Zeek and Zeek pops up with all sorts of CRC errors and then it doesn't actually capture anything because it thinks all the frames are bad, use the -C switch. That'll fix that. Then I said -lowercase r to read in the PCAP file. And then I said local, telling it use your local .zeek file for the configuration. And I've got some things tweaked in there, like changing the TCP timeout from 5 minutes to an hour. That does a better job of catching real long connections. I also turned on features like, hey, I actually want to validate any of the digital certificates you say. Then I took those log files and imported that into Zeek. So you can, into RITA. So you can see RITA went through, parsed the files. It popped up and said no proxy beacon data to analyze. So we won't be able to look for any or hunt for any proxy-based beacons because there's no proxy on this network. However, the process you use is exactly the same as you would for any other type of beacon. The only difference between a regular beacon and a proxy beacon is where the data is coming from. We're pulling data out of the SOX protocol to identify where the system was trying to go versus pulling it out of the IP header. Now, normally what we would do is once we have our capture, we'd go through and would process our safe list. Our safe list is just simply IPs or domains that we've identified in the past as being business safe. I'll give you a great example. Windows.com, right? Microsoft.com. Our Windows systems are patching and checking into Windows notification servers. We may want to add a lot of that stuff to our safe list, so that when we go back later and do a hunt, we're not looking at those things over and over and over again. It helps to, the first time you hunt a network, it's going to be noisy. That helps to reduce the noise over time. There's three basic ways we can go through and do this. We can take the output that RITA generates and run a script to parse that output and remove all the stuff that we knew that's okay. That's my preferred method. And what I like about it is if you shoot yourself in the foot, there's an easy way to back up. In other words, let's say I add something to my safe list incorrectly that isn't actually safe, or maybe I make a typo and it's grabbing too big of a range or something along those lines. Recovery is easy. Fix my script, reprocess the RITA data, problem solved. And in fact, I can even just put my scripts aside and do a full hunt of the RITA data if I need to, problem solved. So there's a lot of ways to back out from making a mistake. I could also use RITA's never include or never include domain variables. I can go in and add IPs and domains to that I want to add. The downside of that is it's not very granular. In other words, with the parsing scripts, I can parse my beacon data using a different safe list from my long connections. I can't do that with the stuff in the RITA config. But the nice thing about the RITA config is if I shoot myself in the foot, delete that data set, re-import the Zeek data, I have a way to back out again. BP filters are a great way to add additional performance. I may want to do this anyway if I have like a couple of gigs of a connection to the internet. That way Zeek's not capturing stuff that we wouldn't care about anyway, like broadcasts and multicasts and that type of thing. So you could go in and create BP filters for your safe list entries, and that Zeek just doesn't even process it, and that'll pick you up some speed. On the upside, it improves performance. On the downside, we didn't collect any data. So if we add something to the safe list incorrectly, if we make a typo, the data's gone, it doesn't exist. There's no way to back that out. The best we can hope for is to fix it and then maybe see it again going forward. So those are basically your three options. And I gave you some links to some blog entries we have that talks about that stuff. But for now, let's go in and do a demo. So what I'm going to be doing is just basically kind of running through the full hunt process. So you can see here, I've got my Zeek logs in here, all my .log files. My .pem is a copy of all my digital certificates. Runbook.pcap is the actual pcap file. And if I say read a list, I've got one data set called Runbook. And that's the one I'm going to go through and work with first. So I'm going to start with long connections, just because, hey, why not start somewhere? Might as well be long connections, right? So I'm going to tell it I want to go through and analyze looking for long connections in Runbook, and I'm going to run that through head to be able to say, just show me the first 10 lines worth of output. Now, for me, my threshold is around 20,000 seconds. That's about 5.5 hours. Anything that lasts longer than that is probably worth going in and taking a look at. And you can see all 10 of them are well within that range, right? 46,000 seconds for the shortest connection out of my top 10. So we've got a lot here we could potentially go in and look at, but I'll talk about some quick ways we might be able to clean some of this stuff up. Now, notice my first line entry here. I've got a 24-hour data set. We saw that in an earlier slide. 24 hours, 86,400 seconds. So this is almost that full 24-hour period of time. Notice that, yes.
We cannot see your screen.
You can't see, okay. Let's see if I can't figure out why not.
Perfect.
How about now? Got it now? Cool.
Yep.
Awesome. Thank you. All right. So yeah, Zeek logs, PCAP file. You can see all that now. Here's my RITA list command. I've only got one data set in there. And here's my show log connections, pumping it through head. So I see the first 10 lines worth of output. And as I said, 86,400 seconds. I've got basically everything from here up is pretty close to that. It's close enough to that the connection probably started yesterday, meaning it started before this PCAP started to get created. Now notice Zeek can't tell what the application layer is. It's listed as a dash. These it recognizes as SSL. When it says SSL, it could be SSL or TLS. But up here, it doesn't know. Part of the reason for that is probably the connection started yesterday or the day before or the day before that. Zeek needs to see the initial handshake. It needs to see the SSL client, hello, server, hello, digital certificate exchange to know, yes, that's definitely SSL TLS. And that happened somewhere in the past. One side effect of that is that that means we won't have a DNS entry for it either. So if I go in and I try to identify what was actually queried to get to this IP address, I'm not going to be able to find anything. So if I go in, let me just copy that real quick. And I'm just going to go in and I'm going to say grep that IP address out of dns.log. And let's see what comes back. Nothing, as expected. So I don't have a fully qualified domain name to work with. I don't have the beginning of the protocol. What can I do? About one of the only few things I can do is I can go in and do a whois query. So I can go in and I can say, hey, let me see what I can find out about this domain. And I like to use CMU for this just because they've got a really rich data set. It's also easy to go through and format that. So I just go through and say, hey, whois -h. I don't want to use the default whois server. I want to point at this one. And hey, go look up that IP address for me. Now, when I do that, it comes back and tells me, oh, that's part of ASN 8075. That's the management network for Microsoft, and that is owned by Microsoft. It used to be anything in 805 you can trust, because that was Microsoft's management network. And then they extended it into Azure, and it became possible to go through and run this as, to go in and run this, launch a VM within Azure and end up as part of this ASN. So that kind of makes me sad because we can't just kind of blindly trust it anymore. So that's one that, yeah, okay, maybe we can trust it, maybe we can't. Now, I could go through and do a threat crowd or an alien vault lookup on this IP address. And I had that in the flow, but quite honestly, Zoom's being a pain. I don't want to have to keep switching between screens. So if we did do that, and I'll give you the commands for that, they're in the slide set. But if you go in and you look up these IPs, both of those tools, Threat Crowd and Alien Vault, tell you that that IP address is part of Microsoft. It has been for a period of time. And Alien Vault even goes through and says that it's, whitelisted it. It said, yeah, no, this is safe. Don't worry about this. Threat Crowd goes through and tells you, hey, this is, a majority of folks say that this IP address is safe. So this gives us kind of a warm, fuzzy feeling, but I'd love to have a little bit more verification than that. Now, if I look at this IP address, 6552.108.225, I've got one really close to that right here, right? 6552.108 instead of 225, this is 233. So it's part of that same Class C, which again is owned by Microsoft. And this one, we did see the initial connect that took place. So we may actually be able to pull out some information about this one. So here's what I'm going to do. I'm going to go through and I'm going to try and pull that out of the dns.log file. So I'm going to go in and I'm going to say cat dns.log, zcut, pull out queries and answers. So I don't need to see all the data associated with this. I just want to see what was queried, what was answered. And then I'm going to say, look for matches against this IP address. And then I'm just going to pipe that through unique because we don't need to see tons of stuff scroll by on the screen. Just one entry is enough. And oh, hey, look, this is a Windows notification server. So sitting a couple of IP addresses away is this Windows notification server. Cool. Well, if it's a Windows notification server, it should be creating an HTTPS connection to it, which means I should be able to go through and see, is there a digital certificate associated with it? And if there is a digital certificate associated with it, was it valid or not? So here's the query I'm going through and doing. I'm catting the SSL.log file. I'm saying zcut, pull out the destination IP address, the name of that server, and the validation status of the digital certificate. Sort it, run it through unique-c. In other words, I don't need to see every instance of it. Just one of them is fine, but just show me how many times it hit it. And then grep this IP address. I only care about it for this one specific one here. So when I go through and I run that query, nothing comes back. Because I have the wrong IP address up there. I grabbed the wrong one. Let's do this. The right IP address is this one here, 233. Here we go. So this is saying that that IP address, the 233 address, is a Windows notification server that had a valid digital certificate. Further, notice that the DNS name we queried matches the name on the digital certificate. Cool. So that means that for this line entry, we can be pretty certain that, yeah, that's just Microsoft doing the Windows notification thing. And I've got 1, 2, 3 different IP addresses that are all part of that same Class C range. So here's what I'm going to do. I'm going to say RITA, show beacons for the runbook. And then I'm going to say grep-v and then that IP address space. So I'm going to say 65.52.128, like so. Oh, and then I got to pump that through head. So what did that do for me? That went through and that removed a bunch of entries, right? We were, where were we? We were around, oh no, not beacons, sorry. RITA, show long connections out of Runbook. Hey, let's go back to where we started. So that's that one. And now I want to go through and say grep-v, and I should put in my backslashes. I know I don't need them, so I'm going to be lazy and not do it this particular time. And I'm going to go through and say, yep, -v out that address space. So let me get some white space in here. There we go. Now let's try this again and then print out my top 10 entries. Okay, so up here, my last entry, number 10, was at 46,000 seconds. That's well above that 20,000 we talked about. Well, notice we're down to 29 now. We've eliminated a lot of those potential entries because a lot of them were Windows notification servers. That made it pretty easy. Cool. Let's go to the next one on our list. So this is 111, 221, 29, 113. It started yesterday, so we won't have DNS. We don't have the header information. But if I look down at my output, oh, hey, look, this is just one IP address away, but we still don't have the header information, so that doesn't help. So let's go in and take a look at where is that IP address? You know, let's see if we can't figure out where is this one coming in from. So if I go in and do my CMU query again and just say, so I'm going to be double lazy and copy paste that. Oh, hey, look, that's looking like another Microsoft network. So I would go through and start running this one down the same way. I'd search through a little bit further and I'd probably have some additional 111 in there, or 111, 221, 29. My guess is I'm going to have more entries than just that. In fact, we could do this. So I'm going to say grep for 111, 221, 29. No, I don't have to bother with sort and all of that, but we will pump it through head just so we get 10. And we did. And hey, look, we've got SSL down here. So here we've got a situation where it's on that same subnet. Instead of 113, it's 107, but it started soon enough that we can actually see the header information in it. Cool. So now we'll go through, we'll do the same thing we did before. We're going to go in and we're going to do a search of the DNS records to see what was the user trying to get to when they went to this specific IP address that's on that subnet that we have the initial start of the connection information for, and we can see, oh, hey, look, Windows notification server, just like we saw last time. Cool. So now I'm going to go through and I'm going to do the same query I did last time of the DNS of the SSL.log file to see, okay, was it actually a valid digital certificate? So if I go through and I search for that, yep, the DNS name matches the host name of that server, and Zeek is saying, okay, that was a valid digital certificate. Cool. So let's go back. Oh, I hate it when you do that. Let's go back here. Actually, I want to go back one of that. That one. I'm going to say grep-v. So now that we know the 111.221.29 network is okay, let me pump that through head. And hey, look, now our top one is this 40, right? That one's pretty up there too, but notice we're down dropping into 6,000 here. And this one, so now we could go through and we could run this one down to see what's going on with it. Let's take a look at whose address space that's part of. Because again, we didn't see the start of the session, so we don't know a whole lot about it yet. I think that's Microsoft address space, but I'm not positive. So let's see, who does that end up being? So if I go through and query CMU, that says, oh, hey, look, it's Microsoft. Oh, and 4077.229, I've got this entry down here I can go looking for. So I can go in and I can say, let's just skip to the chase. Let's just say it's probably going to be Windows notification server, right? And I'm not even going to bother checking the DNS query. And then I'm going to go in and I'm going to say, let's check it on that IP address that's part of that same class C. Windows notification server, certificate was valid. Cool. Now I hit my up arrow. My SSH client gives me a hard time because it can. There we go. And now I'm going to go in and I'm going to say grep-v. Let's see, 40.77.229. So again, all of these grep-vs I'm doing, I would actually add these to my safe list for tomorrow. But I'm throwing them in as just grep-vs right now, just so you can see how quickly this data whittles down. So now we're getting well below 20,000 at the end. I've got this, hey, what do you think this is going to work out to be? Right? Let's go through and let's give that one a shot. My guess is it's probably going to be a Windows notification server. But let's see. We'll go through and we'll check this one out as well. Actually, we can't check that one because that started too early, but this 249 is part of that same address space. So I can go in and I can check that one out of my SSL.log file. And that is going to show me, let's see, do a -v, pump that through head. Oh, wrong one. I wanted to look at this. This is where I wanted to say grep-v 131.253.34. Then pump that through head. That's the one I was looking for. Okay. So we've gone through and we've pulled out a couple of the subnets that we know are Windows notification servers. And you can see we're already down below 6,000 seconds. We said 20,000 was our threshold. So it didn't take me long to go through and kind of whittle out all of the potential long connections to see that, yeah, this is something that we need to go through and figure out. Someone made the statement, hey, why two greps? Why not combine them? Absolutely, you can. Absolutely. Part of the reason I'm just doing it separate like this is just because it's easier to read and it's easier to see where I'm pulling in one versus the other. And I'm horrible at scripting. So there is that part of it too. But yeah, you can see, okay, so long connections, everything we saw that was above that 20,000 threshold, that was something that turned out to be just Windows notification service. Long connections look like they're in pretty good shape from here. Cool. So let's clear our screen and let's go in and say, hey, Rita, show me the beacons. Oh, and it helps if you spell Rita correctly. Show beacons out of Runbook. And I'm just going to run that through head. Okay, here's our top 10. Now, these are beacons, meaning that they tend to be short, bursty connections. So that problem I had before where Zeek didn't see the beginning of the connection, so we couldn't get a DNS entry and we couldn't maybe see what the protocol was, that should not exist here, because these are connections that stop and start all the time. Zeek is going to be able to see that stuff taking place. So let's go to our first entry. So this reader is saying it is 100% certain this is connection persistency. I've got an internal IP address that's talking to this external IP address. It connected 20,000 times over the course of 24 hours. Yeah, I think it's pretty safe to say there's some connection persistency taking place there, right? So I think the first thing we should do is go in and see what was the DNS query that was performed that landed us at this particular IP address. So again, I'm going to go through and I'm going to say cat dns.log, zcut, pull out the queries and the answers. If the query or the answer included this IP address, print it to the screen, only show me one instance of each. So when I go through and I run that, I see, okay, so that system was trying to get to alpha.stjameschurch.org. Huh, that's kind of weird, right? Does that sound something businessy? Not to me, right? I'm not sure what's going on with that one. So let's go in and do our who is query to see who owns that address space. Okay, it's going into DigitalOcean. So that doesn't really help me a lot. Because that's a cloud provider. It could be anybody that's in there, right? So I'm not sure this is something that should actually be happening on my network, but I don't know for certain it's something that shouldn't. I'm still kind of up in the air on what to think of this one. So since I'm still up in the air, the next thing I want to go through and do is analyze the protocol. What type of connectivity was taking place here? That may help me figure out if this is something I need to be concerned about. So I'm catting con.log that has all the connections in it. And I'm saying zcut, pull out the source IP address, destination IP address, the protocol, TCP, UDP, whatever the case may be. Then pull out the destination port, then pull out the decoded service, what application was running across that port, and then I'm pulling out constate. Constate for TCP connections will go through and identify what TCP flags were exchanged as part of that connection. And then I'm just grepping on this IP address that I'm interested in, sort unique C. So in other words, hey, any line entry that's just repeating, only print it out for me once. And when I go through and do that, I can see all 20,054 connections went to TCP 443. This is weird, no service identification, but this really identifies why. The TCP flag state was reject. What does that mean? That means that when this internal IP address tried to connect to TCP 443 at this external IP address, that system said, sorry, I don't have an application listening on that port. Go away. So it rejected the connection. So our system tried to connect 20,000 times to a service it couldn't talk to. And the service is located at alpha.stjames.org. That's kind of odd. So the connection's getting rejected. So I'm not in panic mode because no actual data is actually leaving. It might be trying, but the system on the other end isn't accepting it. But at the same time, I don't know why it's doing this. So what do I do? One little hacks I used to do was if I'm running my own internal DNS, I would set up my internal DNS to be authoritative for stjameschurch.org, and then put in a single record for alpha.stjames.org. And then I would open up port 443, launch Apache and put a self-signed digital certificate on it or something. And then let's see what happens when our system tries to connect to it. What data is it trying to send? That is one possibility we could go with here if we wanted to. The other is we could maybe go in, say something's wrong with this system. Let's go into incident response mode, and let's go through and do an analysis on this box to see what application is trying to cause these connections. So I'm not freaking out about this one, but it does make me a little bit suspicious. All right, let's go to our next one. Because typically I like to look at like 0.8 or higher. That's kind of my threshold. I'll drop below 0.8 if a lot of data is getting moved, but typically 0.8 and higher is what you want to pay attention to. Now notice this. I've got two IP addresses that are pretty close to each other. They're not part of the same class C, but they're in the ballpark of each other, if you will. So one of the things I can go through and do is I can go in and I can say, let's go take a look at the DNS.log file to see what was the user trying to get to when they went to that IP address. So I'm going to go through and I'm just going to paste this one in, copy that, paste it. I'm going to pump it through unique because we only need to see one of each unique line entry. And this was trying to get to AWS DNS-08.net. Okay, so it's trying to get to a DNS server located in Amazon EC2. Okay, that's not anything I need to really worry about. It's kind of weird that it's doing it persistently, but that doesn't necessarily mean that's a problem. There may be something we're accessing out there on a regular basis. If I look at that other IP address that's kind of close to that, that also comes out as being part of Amazon. It's going to the DNS server. So one of the things I could go through and do is see, okay, what is that traffic? I expect it to be DNS traffic. So I'm going to go in and I'm just going to say, let's take a look at the con.log file. We'll analyze the first one here, paste that in, and then just do our sort unique. So we get a summary of information. And when I go through and do that, I can say, oh, I have two internal systems that are doing DNS queries. So it's going to port UDP 53 and it decodes as DNS. So we're using it as a DNS server. So where I would go from here is, what are these two systems, .10 and 11? If they're my internal resolvers, things are okay. If these are not my internal resolvers, these are endpoint systems, why are they making direct queries out on the internet versus going to the internal resolvers? That may be something we might want to go in and pay attention to. But it seems like, yeah, these are just DNS servers. That's not a big deal. This would be another one I could -V to remove out of my data set. So the next one to go in and check out is my third one on the list. So let's go through and see what were they trying to get to when they ended up going to 234, 239, 169, 214. So we paste that in, pump it through unique, and pixel.moteads.com. Oh, that makes me kind of nervous because pixel implies they're placing a single pixel within the environment that is a way to kind of track somebody without it being obvious they're being tracked. What would I do next? The next thing I would do is I would go in and look to see what is this site? Who is doing this, right? And if you go out and you Google this, it comes up with lots of ways to kind of walk you through how to remove the tool. It's a browser plugin to serve up banner ads. It's embedded in a lot of free tools. It's considered bad. So yeah, that may be something we might want to go through and clean up. Now, the next thing I need to figure out is, okay, we're doing DNS queries for that. Who's actually doing those queries? Who's actually going there? So I went through and I said, okay, cat the DNS.log file, Zeek cut, pull out who originated the query, and also pull down the answer because I want to grep that domain out of the answer. So I'm only looking at source IP addresses that went looking for this domain. And then I just went through and said cut field 1. So I want to go through and just look at this IP address only. And then I did sort unique so that I'm only just getting one listing of each IP addresses. And I'm back to these 2 IP addresses we talked about before. So again, if these are DNS resolvers, I need to go to the DNS resolvers and trace back who's sending them these queries because those are the systems that are running adware. If, however, these are just endpoint desktop systems, okay, these things look like they're running adware on them. So it's not C2, it's not the end of the world, but we probably don't want to have adware on them. We need to go in and get that cleaned up. There's our next hit. This is the next one we'd go after. So let me go through and say, RITA, show beacons again. And let's just kind of sanity check where we're at in our hunt at this point here. So we went through this one and said, hey, we're trying to connect to somebody. The connection's getting rejected, but it's 20,000 times a day. We need to do more research. This we said was, hey, these are DNS queries going out to Amazon. Probably not a big deal. This one we looked at and said, hey, that looks like ad software. That's not a good thing. We may want to go in and pay attention to that. This is one we need to go in and kind of clean up on those systems. So let's take a look at the next one that's on this list, this 13 IP address. Yeah. So let's see, what was the user trying to get to when they went to this IP address? Oh, because I have a comma in there. Let's pull out that comma. Oh, and it still comes back with nothing. So we don't see a DNS query associated with this 13 address. That makes me a little bit nervous what's actually going on there. So we don't have a DNS query. We don't know what's going on with that. So let's go in and let's look at what was actually going on in the con log. What type of connectivity was taking place to this IP address, because that might help me kind of figure out a little bit more of what's going on. So I'm going to go through and say, hey, con log, show me this particular system. And I'm just going to summarize any results that are in there. And oh, wait, this is DNS queries going from 3 different systems. UDP 53, it's definitely DNS. SF means, yeah, I saw the DNS query go out. I saw an answer come back. So it was a complete DNS handshake. So that 13 is not one I need to worry about either. Cool. So this one looks like it's okay. This one is part of that subnet space up there. And then we've got a bunch of 23s that pop up after that, stuff that's part of the 23 IP address space. So let's go through and take a quick look at those to see, is this something we need to worry about? Notice I'm doing the same thing over and over again, right? And just for every one I see, I'm going through and I'm just quickly running it down to see, is this something I need to worry about or not? So I'm going to go through and let's see what we get for DNS queries. Oh, the 23s, Akamai Edge. So it's somebody accessing an Akamai customer. Cool. All right. So here's our first 10 beacons. And we just went through all of them and found we've got a connection that's taking place that we don't understand and it's getting rejected. We need to run that down. We found some adware. We need to worry about that. Everything else looked like it was okay. So again, for my hunt tomorrow, I just go in and add a lot of this stuff to the safe list. All right, let's move on. So RITA, show beacons, fully qualified domain name, out of Runbook, pump that through head. And what do we got? Well, we already saw this, right? That was our connections that are getting rejected. And then some of our other ones that popped up, these we already went through and saw, right? A lot of these are the ones that we pulled out by IP. Fully qualified domain name is useful when the C2 server is sitting on the other side of a CDN network. When it's IP to IP, you can run it down in either data set, you're fine. So all of these are okay. These are all things that could get added to our safe list, except this one. That's the one we're not sure about. But from a fully qualified domain name perspective, we're in pretty good shape. All right, let's keep going. RITA, show strobes for Runbook. Strobes are just beacons that are going off more than 250,000 times in a day. In other words, it's going off about 3 times a second or more. That makes them super interesting. Or actually, no, we dropped the threshold on that to 86,400. So if it's going off more than once per second all day long, we don't bother analyzing it as a beacon. If it's going off once per second, you can just look at that and know there's persistency. You don't need math to help you figure that out. And we've got one hit that shows up as part of that. 192.168.88.2 is talking to this IP address out here, and it connected over 100,000 times. Now notice with strobes, we don't have all the neat little data that we normally get with beacons. That's because we're not going through the full math. And again, we're not going through the full math because this is going off at least once per second. So what can we do? Well, one of the things we can do is we can go in and we look at what was the user trying to get to when they ended up going to this IP address, right? That may help us kind of figure out what's going on. So I'm going to go in, I'm going to query my dns.log file. And oh, by the way, you see me copy pasting this stuff all the time. What I usually do is just write a script. I create a script called FW. I add all these commands. I add in the IP address as just a variable. So now I just have to type in FQ space the IP address, and that my script will automatically go through, grab that information out of the dns.log file, and just parse everything for me automatically. I don't have to type in all this other stuff. It just saves an awful lot of time. Wow, look at that. There's a lot of data scrolling by on the screen. Now, just to remind you, I said, hey, grep that IP address, sort unique -C. So I should only see one instance of every time something was queried. Well, that's saying that we queried this. We queried this. We did a ton of unique queries within DNS for all of this stuff. That's kind of odd. So my strobe is DNS queries going off, querying a ton of different names within a specific domain. Okay, how do I get more information on DNS? Well, luckily, I can just say RITA show exploded DNS for Runbook, and I'm just going to pump that through head. And at the top of my list, it's telling me, hey, this domain r-1x.com, we queried 62,468 unique resource records. Okay, we've talked about this, right? For the average environment, they're going to expose 12 resource records or so, not much more than that, if more than that at all. Some of the big players, Amazon, Akamai, you might see a couple hundred. So this is 62,000 plus resource records for a domain I don't recognize, r-1x.com. That makes no sense. That's something that is kind of odd to me. So what I'm going to do now is I'm going to go through and I'm going to take a look at some of the rest of the exploded DNS data, because once it gives me the summaries, after that, it starts getting into my queries. So these are the DNS queries that are taking place. So we looked up that. That's kind of an odd one, right? That's kind of an odd thing to go in and looking for. Let's see. Noopy said, "Hey, would you mind sharing that script?" Sure, I'll happily share it. Although it's something we build as part of the advanced threat hunting class. But yeah, I'm happy to go through and kind of pull that. Data exfiltration via URL hostname. Well, this isn't URLs. This is DNS queries. Notice any patterns here? In other words, when I look at this, and I compare that to, let's say, this query, or I compare it to like this query, do you notice any type of patterns that take place? New command, don't remember seeing show exploded DNS before. Yeah. If you just type RITA, there's all sorts of good stuff in here. And one of them is this one here, show exploded DNS. That's the one we're playing around with. Noopy says base 64. Ooh, you're close. You're in the right frame of mind, let's say. Let me go through and just get some data up here. if I look at these strings, right, if I look at just this part of the information, actually, let me carve this up a little bit to make it a little bit easier to go through and read. So what I'm going to do is, rather than just kind of, instead of looking at it through RITA, let's go through and let's take a look at it through Zeek. So I'm going to say cat dns.log, Zeek cut, query and answer, grep for that r-1x.com domain we were just looking at, and I'm saying head, show me 10 lines worth of output. And when I do that, here was what was getting queried, and here was the answer that was coming back. Notice anything interesting about the host name? The base 64 was close. Nothing higher than an F in there. Good eyes, Radis. Yes. So what uses numbers and letters that only go up to F? Hexadecimal, right? So maybe this is hexadecimal information, which means there might be something encoded in there that's worth going in and taking a look at. So I'm going to change up my query a little bit. So I'm going to say cat dns.log, Zeek cut, query and answer, same as we did before, grep out that domain space. And then this time I'm saying cut -d period -F1. What does that mean? I'm using the cut command to only grab the section that I'm showing here in blue. It's going to grab out the host name that's part of the fully qualified domain name. I'm saying my delimiter is a period, so grab everything before that first period. And then I'm pumping it through the XXD command. XXD is a tool that allows you to take ASCII and convert it to hex. Cool. Well, if I use it with the -R switch, it'll convert hex into ASCII. And then -P says just print it out as plain text. I'm then pumping that through the strings command. The strings command will go through, I forget what the default is. It'll look for like 10 ASCII characters in a row and it'll print that, or it's 5 or 6 or somewhere around there. But with strings, I can go through and say, hey, anything that looks like binary, don't show it to me. I need to see X number of ASCII characters in a row in order to make it worth taking a look at. And then I'm going to go through and I'm going to pump that through less. So I'm going to go through and I'm going to run that command. And when I do, this looks weird. Use 7 capital QI. I'm not sure what that means. So I'm just going to kind of page through my data. We got some additional information in here. None of this looks very odd just yet. I'm sure this is all just perfectly fine. Oh, wait. What do we got on the screen now? Microsoft Windows users, WinLab admin, DAO Go. Okay. IP config. Oh, hey, I recognize that command. That usually prints out IP information associated with particular interface that kind of looks like this, right? Default gateway, local LAN adapter. So we're seeing LAN adapter information. What else do we see in here? Here's some more adapter information it looks like we're looking at here. Oh, hey. WinLab admin downloads 7Z1701-extra7Z installer _payload exe tub exe. We're looking at files in a directory. But wait, these are DNS names. How could these be files? Yeah, I think we have a C2 channel here that is exfiltrating data out and making it look like it's just looking up host names. But it's taking this information and coding it into hex and just making that the host name it's querying. And it's passing it out that way. That way, when you look at it, you say, oh, hey, that just looks like a random string of characters. You don't look at it and say, oh, hey, C users win, volume in drive 8, the file names, oh, this is bad. You don't immediately pick up on that. So it's not encrypted. It's just obfuscated. Let's see, what else do we have in here? Is this more network adapter stuff? We got some more files. Well, we're seeing what services are running. SVC host. Yeah, okay. So we're seeing some services that are running. Oh, hey, that looked interesting. What does this mean? Task kill. Task kill is a tool to use to kill a running process, right? What's it trying to kill? It looks like it's trying to kill Chrome. And then we see PID 7090, one is terminated. So I think it was being terminated. Yeah, Chrome has been terminated. The process Chrome was terminated. So this looked like it was looking for Chrome running, and it went through and it killed that. Office, let's see what else looks in here. So it looks like we're killing processes. It looks like we're listing out processes. This looks really scary. So we're seeing data getting exfiltrated. So now the question becomes, is it just doing it on its own? Or is there an attacker talking to this tool somehow to pull stuff out? So here's what we're going to do. The last command I'm going to run on this is this one, which I can't see because it's up on the top of the screen and the zoom menu is in the way. Awesome. So this time I'm running that same cat DNS. I'm running it through XXD like I did last time, but I got some different commands in through this section here. So what's this stuff? So TR allows me to translate characters from one thing into another. And what I'm doing here is I'm saying, actually, let me show you why I'm doing this. So if I go through and I look at this output, okay, I'm just going to pump this through head. It looks like this. There's tabs in here, there's spaces here, and I want to cut out just this information. So being able to tell cut what to target is hard because there's tabs and spaces all mixed in here. So here's what I'm going to do. I'm going to go through and say, hey, tab, anytime you see a tab or a TR, anytime you see a tab, turn it into a space. And then I'm going to use TR a second time to say, if you see multiple spaces one after another, truncate it down to one space. And what that's going to do for me is that's going to change that output to look like this. See, it just pulled out all the white spacing. So everything's nice and easy. So now I can go in and I can just say, okay, great. Now I can go through and tell cut that my space character is my column separator, and I want column 4. This is column 1, this is column 2, this is column 3, that's column 4. Pump it through strings again. Let's see what we see this time. Okay, we're seeing a bunch of character strings. My guess is this, oh, hey, look at this, shell. Anytime you see shell where you don't expect it, be afraid. So it looks like somebody spawned, this was a way of the attacker to tell them spawn a shell. And then when you do, run the ipconfig command. Well, we already saw in the host names that ipconfig information leaking out, right? And then it looks like they're executing a shell again to run who am I? The net local group administrators. So they want to know what they can try and log in as there. Looks like we're running the dir command. We're cding into the documents directory. We're running the dir command again. We'll go into the downloads directory. Notice what we're looking at here. We're looking at all of the commands that the attacker is sending to our system. Here's that task list command. Here it is. Remember we saw it killing Chrome? Here it is killing Chrome. It looks like it also went through and killed an Internet Explorer as well. Actually, it looks like the attacker typoed and then had to run it a second time to go through and kill it. Interesting. And then they started up Internet Explorer again. So what are we looking at here? We're looking at a C2 channel. This looks like we've got a compromised host that we need to worry about. All right. So we're getting clear that at the top of the hour, let me go through and figure out how to get the share back onto the slides. This one. Okay, so you should be able to see my slides again. We're back at the live demo slide. So here I'm going through, here's all the commands you just saw me run through. So I gave you a copy of all the commands I was playing with, just so you have that. So what did we figure out in this hunt? Right. So we looked at 4 million plus packets, 3 gigs worth of data. What did we figure out? Well, the number one thing we found out, we're leaking data over DNS. There's a C2 channel that the compromised system is doing DNS queries in a remote domain. And that remote domain, the authoritative server for it is actually a command and control server. And when this thing checks in, the attacker is embedding shell commands in the answers, making it look like hex characters. And then that compromised system is just running those commands and then exfiltrating the data back out as host names that are, again, obfuscated to make it look like hex. So that is our number one big concern. Let's hit the big red incident response button. We need to respond to this. The next thing we found, adware on two systems. Okay, this is something we could probably point the help desk folks at. That's certainly not as big as a priority as what we found here. We found traffic going to stjameschurch.org that isn't connecting. It's closed port, but why is the system doing that? So this may be one we might want to pass off to like the ops team or the, local net team or whatever the case may be. And then we found a lot of long connections that were actually turned out to be safe. We can go through and add those to our safe list. So here's, just to review, let me go back to the start again for a second to that summary. So 24 hours worth of data, 4 million packets, 3 gigs, and we just went through that in less than an hour. Not too shabby. So it's not that hard to go through. So as far as like how hard can threat hunting be, you can actually buzz through this stuff pretty quickly. But hey, if you had a commercial tool like AC Hunter, it's even easier because it gives you a simpler interface, threat scoring system to help you identify what you need to focus in on, flexible safe listing. And we are about to come out with a release that has direct support for Azure, which means you can go up to the Azure marketplace and just, buy it from there, deploy it out. It'll run on your desktops, systems, or servers, whatever it is you need to run it on. And if you want to play around with the tool, follow this link to the CTF challenge. The CTF challenge is over. People won. We sent them prizes. All of that stuff went good. But the CTF is still there if you want to kind of get a feel for how the tool works. And with that said, we are done. So if I can figure out, there we go. Getting the camera started isn't that hard. So let's see, maybe they're on a holy mission to better cybersecure via blue teams. Yeah, so like I said, that was a bit of data, and we went through and we hunted that whole thing together in less than an hour. It doesn't have to be that hard. It's just a matter of having the right tools. I'll be honest, figuring out what's persistent is the hard part. And the tools that can really help you out with that is RITA, the tool you saw me using. That's an open source tool. You can download it and use it for free. And you'll learn all about how to use it in that level 1 threat hunting class that I mentioned back at the beginning. Or AC Hunter, our commercial tool, which is fairly inexpensive and gives you a pretty GUI too. So with that said, hey, anybody else want to jump in? Anybody got anything to add before we are done?
Nothing to add, but that was awesome. I mean, really. That was definitely a good one.
See, this is why I drink lots of caffeine.
Absolutely. Nice work, Chris.
Yeah, definitely.
No worries. In KC, I look at you and I want to light things behind you on fire just so you don't freeze.
Oh, I know. And it's really, really dark.
I'm so glad you added the just so you don't freeze part. The person like, I just want to light things on fire.
Okay, I got to say something about this comment. Chris, so calming when you present. Happy little C2s.
I love that one.
Yeah,
another one's like he's got the hair too.
Yeah.
I'm glad you saw that, Chris, because I actually screenshotted that. That made me laugh so much. I was going to send it to you after the That's awesome.
Yeah, and I apologize for not being as active in Discord. But like I said, I wanted to make sure we got through the whole thing within the hour. So, which, hey, we even had a couple minutes to spare. So we could even have a long conversation around cat cheek grease now if we wanted to, or at least for the next 60 seconds. Because it all comes back to kitty cheek grease. At the end of the day, it comes back to kitty cheek grease.
Sounds like a really bad Western, Chris. Hey, for anybody who's asking about the PCAP, remember, if you go up to www.activecountermeasures.com, go into the blog and search for malware of the day. We have PCAP files that are both 1 hour and 24 hour for a whole bunch of different things. So if you're thinking to yourself,
what you saw me just do that.
Absolutely.
Yeah, I'm throwing a link in the Discord. It'll put you right into the categories. So.
Okay, Keith, apparently your new stripper name is Kitty Cheek Grease. I can't even say that. I'm just
cheek grease.
Oh, is that because of Major Tom behind me?
Oh, maybe.
Yep.
Or just, out of all the people on display, you look like the one that would most likely have a stripper name.
Wouldn't that be Sergeant Cheek Grease?
Yeah, that's true.
Sergeant Major
my.
cheek grease.
And Augustine, you're right. I cannot say that with a straight face.
That's awesome.
Cool. Well, we were at the top of the hour. If nobody's got anything else, we are done. So
Yeah, actually,
Yep.
I'd just like to add one more thing.
go for it.
Like information security tools can be very, very expensive, as we all know. And I'd just like to point out that everything you just did is all free tools. I mean, this literally costs nothing to do what you just did. So
Yeah.
that's an awesome thing.
Other than 60 minutes of your time and 30 minutes of your sanity. That's all. It's the only cost.
Yeah. No, I mean to actually hunt the network in that fashion using, RITA, Zeek. I mean, that they're open source tools. I mean, so to me, it just goes to show that, you don't necessarily, have to, spend $100,000 to look for beacons in your network. I mean, you can
exactly.
You can start
Yeah,
doing
save
that
that.
as soon as this cast is over. So.
Save that for the McLaren.
Yes. There you go.
So Freak Mod wanted to know, how do you ask your barber stylist to cut your hair? So number one, I never let a guy, because they always want to cut it shorter. And this is going to sound bad, but anyone who has any association with the military, I find if I tell them I want to leave it long to them means something different than what it does to me. So I try to avoid that. And if they have curls, all the better. But that also implies that I actually go to get somebody to get it cut, which I don't do that often. So. Cool. Yeah, I just had to stop and talk about my hair. If we're going to talk about Keith's cheek grease, I got to talk about my hair. So,
Well, I'd actually like to say I do not have cheek grease.
yes. No,
Are
that's
you
just
sure
a
you
stripper
rubbed
name.
up against your camera? Are you sure?
Yeah.
To find
I
out what
have cheek-
happens?
I have cheek
You
fur.
have, Ryan.
Yeah, Eric G has it right. Deny, deny, deny.
Yeah, exactly. I'm pleading the fifth.
Yes. The fifth. No, we won't go there.
Nope.
Fifth of vodka.
All right.
Yes,
So
vodka.
if you want to see the replay of this presentation, it will be on YouTube. And I saw somebody shared the link in our Discord already. You can find our Access Active Countermeasures YouTube channel. If you need to find it later, you can get the recording there. And I think we're done.
Yeah, I think we're done.
Thank you, everybody.
Yeah,
We
thank you,
appreciate you
folks, for
taking the
turning
time.
out today. Yeah, appreciate you everybody's time.
Cool. I'm going to hit end the Zoominar for all. Bye.
Later, folks.
Bye.
Bye-bye.
Ciao.